In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much. Okay, today I'm going to discuss my lecture number 39. Oil and gas production, exploration, production, upstream, midstream, refining, petrochemicals, differentiated performance, enabling profit optimization process. Lecture number 39. Before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wa halal uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue, that they may understand my sayings. Allahumma Rabbi zidni ilma. O Allah, advance me in my knowledge and true understanding. Okay, oil and gas production. We have discussed introductions, facilities and process management systems, reservoir wellhead management systems, upstream facilities, midstream facilities and management system, refining facilities, petrochemicals facility management systems, utility system. Today we are going to discuss unconventional, conventional resources, environmental effects. So today we are going to discuss first a topic on conventional and unconventional resources. Okay, what is the ultimate goal? Shipping the clean and sustainable global energy delivery. Plan to deliver more than 300 lakh in next couple of years. Okay. Oil and gas productions, unconventional and conventional resources and environment effects. Lecture number 39. Unconventional sources of oil and gas. So extra heavy crude, tar sands, oil shale, and shale gas and coal bed methane. We are going to discuss today. Okay. Okay, key takeaway points, lecture number 39. Unconventional resources, oil and gas, extra heavy crude, tar sands, oil shales, shale gas, and coal bed methane. Okay. Okay, unconventional conventional resources of oil and gas. As per IEA 2012 statistics, about 81.1% of the world primary energy consumption in 2012 was of fossil fuels. 27.3% was coal, oil production was 32%, about 4.01 billion tons, and 21.4% was gas, with 339 trillion CSM or 3.01 billion tons oil equivalent, that is TOE. So the total oil and gas production was 6.4 billion TOE. So tons oil equivalent, which is about 128.5 million barrels of oil equivalent per day, was consumed in 2012. Proven reserves are estimated 201 billion TOE of oil and gas, 6,707 TSV of gas, 180 trillion CMM, 160 billion TOE for a total 361 billion TOE converted from estimates by US Department of Energy 2012, indicating that proven reserves will last for about 56 years. Okay. Okay, unconventional sources of oil and gas. The reservoirs described earlier are called conventional sources of oil and gas. As demand increases, prices are soar and new conventional resource becomes economically viable. At the same time, production of oil and gas from unconventional sources becomes more attractive. These unconventional sources include a very heavy crude oil, oil sands, oil shale, gas and synthetic crude from coal bed methanes, methane hydrates, and biofuels. At the same time, improved oil recovery IUR can improve the percentage of existing reservoirs that can be economically extracted. These effects are, as you can see in the diagram here. So if you can see here, if demonstrate here, this red line here. So this area is IUR, improved oil recovery. So that is over here in the yellow area here, and this is a recovered oil. Okay, so this is the recoverable oils and production, and over here this is the explorations. So IUR, improved oil recovery, and non-recoverable area over here. Okay, so based on that, estimates of undiscoverable, conventional and unconventional sources vary as widely as the oil price among different sources. So this figure illustrates that if one assumes that if an oil price is $100 per barrel prevails, the estimated economically recoverable reservoirs with a current technology will be about 800 billion tons of oil equivalent, or TOE. 45% is proven. This is about 125 years of consumption at current rates, and is expected that up to a third of oil fuels productions may come from unconventional sources within the next decades. Okay, extra heavy crude. Extra heavy crude, very heavy crude, or hydrocarbon with an API grade of about 15 or below. The most extreme heavy crude currently extracted is Venezuela, that is 8 API crude, for example, in eastern Venezuela. If the reservoir temperature is high enough, the crude oil flow from the reservoir. In other areas such as Canada, the reservoir temperature is lower and steam injection must be used to stimulate a flow from the formation. When reaching the surface, the crude must be mixed with diluent, often LPG, to allow it to flow in a pipeline. The crude must be upgraded in a processing plant to make lighter synthesis crude with a higher yield of high-value fuels. Typical syn crude has an API 26 to 30. The diluent are recycled by separating them out and piping them back to the wellhead site. The crude undergoes several stages of hydrocracking and coking to form a lighter hydrocarbon and remove coke. It is often rich in sulfur, source crude, which must be removed. Okay. My next slide, we're going to tar sands. Okay, tar sands. The tar sands can often be steep-minded. Typically, 2 tons of tar sand will yield 1 barrel of oil. Typical tar sands contains sand grains with water envelope covered by bitumen films that may contain 70% oil. Various fine particles can be suspended in the water and bitumen. This type of sand can be processed with water extractions. Hot water is added to the sand and the resulting slurry is piped to the extraction plant, where it is agitated and the oil skimmed from the top, provided that the water chemistry is appropriate. The water is adjusted with chemical additives. It allows bitumen to separate from the sands and clay. The combination of hot water and agitations, if you can see over here. So this is my sand particles here, and these are small fins here, and this is a blue color is a water envelope, and this is called bitumen films. Okay, that is one molecules of tar sand. Okay, the agitation releases bitumen from the oil sands and allows smaller bubbles to attach to the bitumen's droplets. The bitumen's fourth floats to the top of the separation vessels and is further treated to remove residual water and the solid. It can be then transported and processed in the same way as extracted heavy crude. It is estimated that around 80% of tar sands are too far below the surface of the crude open cast mining techniques. Techniques are being developed to extract the oil below the surface. This requires a massive injection of steam into the deposit, thus liberating the bitumen underground and channeling into the extraction points where it can be liquefied before reaching the surface. The tar sand of Canada, Alberta, and Venezuela are estimated at 250 billion barrels, equivalent to the total reserve of Saudi Arabia. Okay, oil shales. Most oil shales are of fine-grained sedimentary rocks containing a relatively large amount of organic matters from which significant amount of shale oils and combustible gas can be extracted by destructive distillations. Significant shale plays have been discovered in the last decade, such as Massachusetts in the North US and Canada, Eagle Ford on the US East Coast, and Bacons in the South Texas. Oil shales differs from the coal in that organic matter in the shales has a higher atomic hydrogens to carbon ratios. Coal also has an organic to inorganic matters ratio of the more than a 4. 75 to 5, while oil shales have a higher content of sedimentary rocks. Sources estimate the world reserves of the oil shales at more than 2.5 trillion barrels. Oil shales are thought to form when algae and sediment deposits in lakes, lagoons, and swamps where an anaerobic, oxygen-free environment prevents the breakdown of organic matter, thus allowing it to accumulate in the thick layer. These layers were later covered with overlying rock to be backed under high temperature and pressures. However, the heat and the pressures were lower than the oil and gas reservoirs. Shale gas can be steep mined and processed with distillations. Extractions with fracture and heating is still relatively unproven. Most of the companies are experimenting with direct electrical heating rather than steam injections. Extraction cost is currently around $25 to $30 per barrel. Okay. Conclusion. Today we have discussed conventional and unconventional sources of oil and gas, extra heavy crude, tar sands, and oil shales. Okay, next topic, we're going to coal gas to liquid and synthetic fuel. Methane hydrates. Okay, references: Qatar Petroleum, Doha, Qatar; Oil and Gas Development Corporations Limited, Pakistan; World Energy Outlook 2013; US Geological Survey; US Department of Energy; Schellenberger's Oilfield Glossary; International Energy Agency IEA; Wikipedia; Oklahoma State Marginal Well Commission Pumpers Manual; State Oil Fact Sheets Nordic Standard Norway; The Story of Oil in Pennsylvania; Air Liquid Gas Encyclopedia; Natural Gas from the Wellhead to Burner Tip. Okay, together everyone achieve more. Please do not hesitate. Send me your feedback, comments, t.masood.dr@path.edu. You can also send me your input on WhatsApp. I have provided my WhatsApp number as well. Thank you very much for your precious time. Please stay at home, stay safe, inspired, and blessed. Thank you very much.